Hello students, welcome to the concept image sampling and quantization. This is a second step in converting analog image into digital image. In the last video I explained about image sensing and acquisition. That is the first step in converting analog image into digital image. So after sensing and acquiring the image, we'll get analog image. So to convert that analog image into digital image, you have to go for image sampling and quantization. What is image sampling? We know the pixel is represented with two things, its spatial coordinates and intensity. So to convert analog image into digital image, you have to do some operations on both coordinates and intensity. So digitizing the coordinate values is called sampling, and digitizing the amplitude values is called quantization. Here amplitude means intensity. So digitizing the intensity is called quantization. So when we do sampling and quantization for an analog image, yes, it can be converted into digital image. So now we'll explain that process by taking this image as an example. See, this is the first image. Okay, this is the analog image. And here consider a line AB. Okay. Then this is a scaling line from A to B in the continuous image used to illustrate the concept of sampling and quantization. See, is how we are getting this image from this. See, we considered a line A to B. So now you start from A. From this end, from A to this point up to this segment is in white. Okay, means high intensity. So the intensity profile is high. See here, this is the high intensity profile. And assume that there exists some random noise in the image. So that is represented with all these random nature of the signal. Okay, then. Yeah, as A and this point is in white, means high intensity level. In the intensity profile, yes, we have drawn that profile, we have drawn that segment at high intensity level. When you are moving from this point into the image, what you see? Suddenly the intensity level decreased. Okay, so that is the reason suddenly the intensity level decreased here. See here, this is the decrease. And then when you are moving into the image deeply, yes, this is all something light gray, means some bright levels. So gradually it is increasing from dark to bright. So see this is a gradual increase. Then after that, when you are moving towards the line and you are moving towards the end of the image, again you are going to the dark side. So that is the reason it is the dark side. Okay, and compared to this side dark is high. That is the reason we went very deep to the dark. And then from this to this point, yes, again we entered into the high intensity level. So this is the high intensity level. Okay, so this is the way of getting this profile, intensity profile from this line AB. Okay, done. Yes, we did this intensity profile. Then what you have to do? Okay, then now for this intensity profile, we have to do sampling and quantization. What is the meaning of sampling? Yes, digitizing the coordinate values is called sampling. See this. Here is the sampling scale. Here is the sampling profile. See. Yes, your total profile is divided as a small square. See the squares, the small squares. Okay. Yes, all these squares are at equal distance with respect to this distance from the sun. These are all samples. With respect to this distance, we sample the intensity profile, and those samples are squares. Means we discretized the coordinate value. Okay. Actually, before this sampling, yes, if you see the intensity profile, it is continuous. But after sampling, the profile is not continuous. It is discrete in nature, and these discrete instants are represented with small squares. Okay, so that is about sampling. Now, again, if you see all these squares, their intensity levels is continuous. So if you see all these squares, their intensity levels is continuous. We sample the coordinates, we discretize the coordinate values, but not the intensity values. So now to digitize the intensity values again, we considered an intensity scale like this. See this scale. It consists of totally 8 levels. Okay, so this is the process of quantization. Yes, it consists of 8 levels. Now what you have to do? Yes, now we'll start with this scale. This is the first level. Let it be 0th level. Yes, yes. Now you have to check how many samples are fitted in this level. So if you observe, these two are very, yes, this sample is exactly in the middle and this is very nearer to this upper level of the first level. So these two are approximated as having same intensity. That is the reason in the output image, the two samples are at the same intensity level. Then go for the second level. Again, you check how many discrete samples are fitted in this. So this side it is 1, this one, and this side it is 1. So only you got 2 samples at same intensity level. And then you have to check this third one. So you check how many discrete samples are fitted in this level. So from this side these are 2 and from this side these are 2. For these 4 pixels at same intensity level. Here you have to remember, when a sample is at a height of, suppose let this be the third level. Suppose if it is greater than 2.5, then you have to approximate it as 3. Means you have to go for this upper level. When it is less than 2.4, yes, you have to make it as 2. Means you have to go for second level. Okay, so in that way you have to get your discretized intensity values for your pixels. So in the same way you have to check this level and how many samples are fitted in this intensity level. If the sample's intensity is greater than that particular 0.5, then assign the upper level. If it is less than 0.5, assign the below level. So in that way, yes, you go like this. Then if you see this top level, in the top level, here 4 samples are fitted and here 4 samples are fitted. So totally these 8 samples are at highest level. And if you observe this image, these heights are different, small differences are there, but all these are fitted in this level. So yes, all these 8 pixels are at same intensity levels at the output side. Okay, so now this is called the digital scan line. Now what you have to do in the reconstruction process, yes, the pixels, these 4 pixels and these 4 pixels must be at the same intensity level. And we discretized the coordinate values and also discretized the intensity values. So what you're going to get? You're going to get perfect pixels, yes, and perfect intensities. No pixel is having two different intensities. Means one pixel is having one intensity, and the pixel means it's a complete pixel. It is not like this gradual image. So if you observe this, see this is the analog image, this is the discrete image or digital image. See, if you say this analog image, it is continuous, means it is not occupying this total pixel region. But if you see this, these pixels, all these pixels are completes in the squares, and every pixel is having only single intensity. But here pixels are having different intensities. One pixel is having different intensity, but here one pixel is having same intensity. Okay, so this is the analog image and this is the digital image. So now what you have to do to get this? This one AB line is sufficient to get this entire digital image? No, you have to start from this top, and continuously you get these AB lines, continuously you get all these AB lines, and do the same process for all these lines. You'll get different digital scan lines, combine them you'll get this digital image. Okay, so this is the image sampling and quantization. So now this is a small thing regarding the representing digital images. Image can be represented as an array. Yes, a continuous image is converted into digital image f of x comma y, and see the rows in the image are m and the columns are n. Means if you see this is all columns. N columns means this is all columns, second column, third column, rows m. Okay, so this is m by n image, m rows and n columns. Okay, and here this is the x-axis. So how is this? See, this image is like this. Yes, this is your x. and this is y. So x is from 0 to m minus 1 and y is from 0 to n minus 1, where m is the number of rows, n is the number of columns. Okay. Yes, how you'll get this rows and columns? Only after sampling and quantization. Okay. So, thus for example, the value of the digital image at the origin is f of 0, 0. See, this pixel is f of 0, 0. Okay. If you want, you can check this. This is the f of 0, 0. Okay. Then, and its value at the next coordinates along the first row is f of 0, 1. This is the first row. This is the second row, and this is the third row, and this is the first column, second column, third column. Though I'm speaking like first column and first row, its numerical representation is 0. Okay. So what about this? This is f of 0, 0, means 0th row and 0th column. Now, if you move to this point, what about the row? The row is same. It is the 0th row, but the column is changed. The column is second column. Numerical representation is 1. So that is the reason its representation is f of 0, 1. Okay. Suppose if we want to represent this, what is the row? The row is m minus 1. Okay. And what about the column? Column is the first column 0, m minus 1, 0. Okay. So in that way you can represent the total digital image as a two-dimensional array like this. See this matrix. Okay. It starts with f of 0, 0. And the last pixel is f of m minus 1, n minus 1. Okay. And what about the number of pixels? The number of pixels are m into n. An image, the number of pixels are m into n. Another important point is, for a grayscale, the intensity levels are 256. Okay. And a general representation, the discrete intensity interval is 0, L minus 1. And due to storage and quantizing hardware, the number of intensity levels L is taken as 2 power k. So the bits required to store m by n digital image is m into n into k. What is this m number of rows and what is this n number of columns? And you have that number of pixels, and every pixel is, suppose take gray level image, every pixel is 8-bit image. Okay. So how many bits are required for that gray level image? You have to multiply, means you have to get the total number of pixels, and for every pixel, yes, you have to assign 8 bits. So totally the number of bits required to store a m by n digitized image is b is equal to m into n into k. So if m is equal to n, then b equal to n square k. Okay, so what is 1 by k bit image now? Yes, for a intensity, for a gray level image, k is 8. Okay, and for color image, k is 24. Now, what I told during the sampling and quantization, sampling means digitizing the coordinate values and quantization means digitizing the intensity. Then, how to do that sampling? Means you are cutting or you are slicing the coordinate values, you are discretizing the coordinate values. How many number of samples that you have to take? In the same way, you are discretizing the intensity. How many number of intensity levels you have to take? There exist specific values for both coordinates, means discrete values of the coordinates and discrete levels of the intensity. Okay. The first thing is called spatial resolution and the second one is called intensity resolution. What is the spatial resolution? It is a measure of the smallest discernible detail in an image. Can be stated in line pairs per unit distance and dots or pixels per unit distance. Okay. So the spatial resolution means how many samples you have to consider for the coordinates. Okay. So that is called spatial resolution. It is measured in terms of line pairs per unit distance or dot or pixels per unit distance. Dots per unit distance is commonly used in printing and publishing industry, and these are the examples of DPIs for newspapers, magazines and glossy brochures. Okay. Yes. So spatial resolution is measured by DPI, dots per inch. And coming to the intensity resolution, it refers to the smallest discernible change in intensity level And number of intensity levels usually in an integer power of 2. Yes, that is because of storage is easy of storage, and also refers to number of bits required to quantize intensity. Okay, so how many number of bits are required to quantize the intensity is called intensity resolution, and how many samples that you are considering to discretize the coordinates is called spatial resolution. Okay, so remember, but this spatial resolution and intensity resolution must be having some specific values, otherwise what will happen? I'll give you one example. See, this effect of reducing the spatial resolution of a digital image means you are sampling the coordinate values. Now, yes, now if you take different values, then how the image will be affected. See this, the first image is 1250 dpi. Okay, 1250 dpi. Dpi means dots per inch. Okay, and the second one is 300 dpi. You know, the spatial resolution is generally represented by m by n. Even you can represent like this also. Okay, and this is C is 150 dpi and D is 72 dpi. So if you goes on decreasing the spatial resolution, what will happen? You're not getting this borderline. Yes, all this borderline gets damaged. And the small information, see this needle scale, and you are not able to see that needle scale. All the small informations, or we lost all the small informations, and this border is also disconnected. So we are losing much of information if the spatial resolution is decreasing. Then coming to this effects of varying the number of intensity levels in a digital image means intensity resolution. See the first one, it is of 256 gray level, means it is normal gray level image, original image. Then the second one is B to H, or the image is displayed in 128, 64, 32, 16, 8, 4 and 2 gray levels. This is 128 image, and this is 64 image, this is 32, this is 16, 8, 4, 2. What is the meaning of image with two intensity levels? It is nothing but binary, okay, black and white. So if you goes on decreasing the intensity levels, what is happening? Here also we are losing much of content. See this, when the intensity levels are decreased to 2, we got only binary image. What is the purpose of taking this binary image? We are not getting any information. If you observe, it has so many details and so much of information, but when the intensity level is decreasing, we are losing so many information details. Okay, and see this level 4, the intensity level 4. Yes, here we are not getting anything. We are not getting even a small information. And now if you increase the gray level, we are getting good information like this. So this is the effect of varying spatial resolution and intensity resolution. Okay, so while doing sampling and quantization, you have to be care while choosing the intensity levels and also the sampling levels. Okay, so this is about image sampling and quantization. Thank you very much.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.